All right, mathletes, here's A3 polynomials and factoring. First thing we got to talk about here is some vocabulary. So when we talk about a monomial, it's a one variable with a constant, and it can be raised, the constant could be raised to a power, and so could the variable. There's no addition or subtractions, so this is what we're going to call a monomial. Okay, we want to make sure our k is greater than 0, because if it's not, you have a negative power in there. And remember that if we have x to the negative k, that's equal to 1 over x to the k value. So we'll actually have a function that is not a polynomial, but it's going to be a rational function because we have things in the denominator. Okay, a needs to be a constant. That's also called our coefficient. When we talk about a degree of the monomial, that's going to be dealing with the power of k. So if it's x squared, we're going to say it's a degree 2 monomial. So a polynomial is one variable is an algebraic expression of the form looking like this, which is a sum and difference of a bunch of monomials. So there's multiples. Notice that we can have constants in front of our x values, okay? And those are called coefficients. When n is greater than 0, it is an integer, and x is a variable. Okay, so x is what's going to be changing, typically our independent variable. Okay, if an is not equal to 0, okay, it is called the leading coefficient. N is a degree of the polynomial, so it's for your largest n there. That's how we'll define our polynomial, by that largest n in that degree. So dealing with polynomials, we'll have to do some basic algebra. So for this operation in part A, we want to understand the structure here and understand that we have 3 times this quantity. So if we want to do 3 times that, we have to distribute to all of our terms. So I get 3x squared minus 9x plus 3. I also want to distribute this 2 to all these terms here. This is going to be plus 6x squared plus 2x minus 8. At this point, I should recognize I have a string of monomials, so I want to collect like terms, things that have similar degrees. So all my x squared terms, so this term and this term, that's going to be 9x squared. And then I want to look for anything that is a degree 1. So I have a minus 9x plus 2x, so that's going to be a minus 7x. And then I'm going to look for any constants, things without an x value. I have a plus 3 and a minus 8, so that's going to be a minus 5. So now I've rewritten, and this is in standard form of a monomial, 9x squared minus 7x minus 5. This would be a degree 2 because my leading term has an x squared. This is the largest power that I have. This is x to the first, so I read this as x squared there. For part B, if I want to rewrite this out, I'm going to want to double distribute here. So I notice that I have a term that's squared there. So even though that we don't have our numbers in here, but our constants are actually variables, that's fine. We can still do the multiplication throughout. So if I want something squared, that's something multiplying by itself. So that means to simplify this, I need to double distribute these terms. So I need to make sure that x is being multiplied by x, that x is being multiplied by negative a, and then also I got to multiply negative a to x and negative a to negative a, so I get plus a squared minus x squared from that second monomial. So at this point, again, I want to collect my like terms. I should notice that I have my x squareds. I have a plus x squared, minus x squared. So they cancel each other out. So I don't have any x squared terms left. And then my linear terms are the ones with just a x value. I get a minus 2ax from those 2 terms. And then my constant is something variable monomials without any x values. Well, that's just going to be plus a squared. So now I've written this in standard form. All right, let's look at some other examples. So we're going to be factoring polynomials here. To factor a polynomial, the very first thing is we want to look for a greatest common factor. So remember when we're saying factoring, we might have a string of monomials being added together or subtracted together, but I want to find two terms that when I multiply them, or possibly three terms or more, but I want to multiply things that are equal to this. Okay, so that's what we mean by factoring. So first thing is find your greatest common factor. So what can go in to all three of these terms? Sometimes it's nothing, sometimes it's not nothing but 1, but here I have a 2, a -4, and an 8. Well, I can recognize that a 2 can be factored out. From here I get 2 times what? That's going to be x squared minus 2x plus 4. Okay. Then I want to say, all right, how can I factor this? So I already have one factor, 2 times something. Well, two linear terms multiplied together are going to equal a quadratic. So what are those two linear terms? Well, I need things that are going to add to be -2 and multiply to be 4. Well, at this point, so at this point, I recognize that no two numbers that multiply to be 4 can add to be -2. So my factors are just going to be 2 times this quadratic. And that's as simplified as I can get that. So here, I want to look for terms. So I like to do what we call the diamond method. So I look for things that will be multiply to -12 and add to 4. So I am going to get 6 and -2. They multiply to be -12 and they add to be -4. So when I collect and break this up, I can see that this middle term can be written as plus 6x minus 2x minus 12. I know that this is equivalent to this, that 6x minus 2 is equal to 4x. From here, I can look at grouping, factoring by grouping. So I look at my first two terms. What are those greatest common factor of those two? Well, they both have an x. I factor that out and I get x plus 6. My next two terms, I factor out what's common between those. Well, they both have a -2. Factor out a -2 and I get x plus 6. I know I've done things right because I can recognize that this term and this term's the same. So if they're the same there, I can factor that out. So then I get x plus 6 times, well, what was x plus 6 times by? Well, first it was multiplied by x, and then it was multiplied by x minus 2. So I can see that this can be factored into x plus 6, x minus 2. I know I can check my work here by double distributing and just do x times x. I get x squared plus 6x minus 2x minus 12, and I can see that this is indeed equal to x squared plus 4x minus 12. Check my work. Okay, for part C here, sometimes our greatest common factor is going to be an x term. Well, here I have an x cubed and here I have an x squared, so they both have at least two x's that I can factor out. What's left over is going to be an x minus 3, and there I have factored that polynomial into two different terms. That concludes our notes for today. Go ahead and highlight any questions and bring them to class tomorrow.